My name is Rakhim. I work at a company called Hexlet. We make online courses. And over the last few years, I kind of stopped programming, mostly. Before that, I was doing mostly web development, some Windows development. And back then, about 5 years ago, Angular was all the rage. React was just released. Angular was the future. We all needed to learn Angular. And then lately, I've been coming back to it, and I've been feeling like, what happened? Like just 5 years, something happened. So I make a webcomic about programming on my website called Honestly Undefined. And this is the most important, the most popular, most important comic I did. It's called React Expectation versus Reality. This is the expectation. This is what they were selling me. Like, it's all simple. You just take data, you can into a function, and then it's just you. And it's so deterministic. It's all simple. And then you say, okay, yeah, I like it, and you go in, and it's that, the reality. So you do have that core, but around that you still have JavaScript. Then you have multiple versions of JavaScript. You have Babel to think about. Then you have node packaging. You have this black hole of node modules folder, and you have literal devil called Webpack. So I want this. I wanted to go back to this, and it turns out you kind of can without JavaScript if you go into Clojure. So just so do I have to follow this or not? Can you raise hands if you kind of tried Clojure, maybe have some experience, did some anything? Okay, perfect. All right. So in 2 minutes, it's a dynamic compiled programming language. It's a dialect of Lisp, so there's lots of brackets. It's kind of weird to switch, but it's fine. It works on top of JVM. It's general purpose, but let's say it's functional. It's not functional in a sense like Haskell is, but let's say it's functional. And the important part is homo-iconic. And that weird word means that the programs in Clojure are written using data structures of the same language. So it's that thing where data is code, code is data, that anyone who does functional programming is going to tell you every day about. And it's data-driven. So you have these primitive data structures, lists, vectors, which are basically arrays, maps, and sets, and they are immutable, meaning you cannot change them once you created them, and any change you facilitate, you have to create a new data structure based on some previous state. So the core philosophy of the language is the data is the core, so you should keep it simple. You don't need classes, you don't need inheritance, stuff like that. You have data. Another core philosophy principle, which kind of is nice, is that mostly it consists of small composable libraries. So many people try Clojure and then they ask, what's the Rails of Clojure, or Express.js of Clojure, and it's not there. Not because people don't want it, but because actually, yeah, people don't want it. People want small composable libraries. So in case of Clojure, if you want some framework for web development, for websites and backend, say, you take a small library just for routing, and then you take a small library just for small abstraction over HTTP. And if you need templating, you take a small library for templating, and you connect them, and you connect them like a Lego set. Everything is connectable, everything is composable. And the thing about Lego is, if you make some Lego parts, connect them into like airplane or something, this new thing is still a Lego piece. It has the same properties as the smallest Lego piece. You can still connect it to other parts. So in this case, it's quite a stable language, meaning, say, you are writing a web app and you need some library for JavaScript, and you go to GitHub, and it says last commit 2014. You're thinking, nah, it's probably like abandonware. It probably won't even work today, because I have like 5 versions of JavaScript on top of that. If you go and Google for a Clojure library, sometimes you do have that, like last commit 4 years ago, but it will work. It's fine. This language and the ecosystem is kind of like Lego blocks compared to some other languages, sexist Chinese toy set that assumes women should cook. Remember this nightmare. So I wanted infrastructure to be simple as well. And in Clojure, it is simple. You have this one thing that you have to kind of learn. It's called lining, or just line. And it replaces all of those. So it does scaffolding, it does building, it does deploys if you need, it does package management and dependency resolution, all that, just one tool. And it's kind of wonderful. I'm going to show you in a moment. Now, ClojureScript is Clojure to JavaScript compiler. As you know, anything in nature can be compiled into JavaScript. So Clojure can too. It takes advantage of this thing called Google Clojure with an S. We should talk about confusing names. And it's a compiler about 15 years now. Google develops this compiler, and it just takes JavaScript and produces really fast JavaScript. And they use it for all the apps, as I know, Gmail, Maps, etc. The thing is, if you want to write code that will be compiled through Google Clojure, you have to follow some rules, and you kind of have to write somewhat ugly JavaScript. The good news is, if you write ClojureScript, you don't write JavaScript, but the JavaScript that it produces is then accepted into Google Clojure. So it kind of creates that ugly JavaScript. You don't see it, but in the end, you have highly optimized, Google-approved JavaScript. And it actually allows for some data sharing between backend and frontend. And the weird part is it can actually be faster than JavaScript for React. And that's because of immutable data structures. So a short demo I want to show is how you just start and go. Involves these pieces on top of Clojure, of course. The ClojureScript, which is just another dependency in your package manager. Liningen, that thing that will do scaffolding and dependency management. And then two small libraries. One is called Figwheel, which is amazing, and it just hot reloads your page. I'm going to show it to you. And Reagent is a thing that does React abstraction. So you can work directly with React with JavaScript, but you don't have to for the most part, because you have this thing. Okay, so how does this work? I'm gonna go and do this line new, and then I say Figwheel, which is the name of the template that I'm gonna use, and that's the thing that will allow for hot reloading. And I'm gonna go with demo 3, because I did some testing before. And I'm gonna also say that I need as a dependency that thing called Reagent, which is gonna give us React. So we created this folder, demo 3, which I'm gonna cd into, and then I can do, as it says, line Figwheel. It will just run my server, or I can run my editor and run the server from there. So let me do this and this. Usually, if you have an editor that somehow you have some plugin for Clojure and ClojureScript, it will allow you to just run the server and run an actual REPL from the editor. And that's what I'm trying to do. It's kind of slow on the first run because it is Java. Like deep inside it's Java, so, but you don't have to think about it. What I have here is my code, the REPL, and the page. So first thing, let's look at this project CLG file. This is kind of package JSON. And as you see, Clojure and ClojureScript are both just dependencies of this project. So you don't have to worry about versions like you have with, I don't know, with Ruby, we have to RVM or RBenf, something like that. You don't worry about versions of languages, it's just a dependency, and then I have some other libraries. This is the file that actually is responsible for this page. Let me try something. Let me create a new state, something to hold whatever state I want. And I'm gonna call it a message. And it will be, I said data structures are immutable, but you need mutable data structures because you want to change state, right? So there are things called atoms, and Reagent takes advantage of those atoms. and let's say this is my message. And this function is kind of a React component, so you can define how your component looks and what state it takes in. Let's say this h1 will be the value of my message. And here I saved and I did a mistake somewhere. There's an error, so it shows on the web page. This is thanks to Figwheel. It hot reloaded the page without me doing anything, and it said I did something wrong. The thing I did wrong is that def-n is for a function, so I'm supposed to define like a constant, but I defined the function. So let me fix this, and now it's supposed to work. Here I have my message. Let me show how you facilitate any sort of state change. I'll make a new function called render, just like you would do in React component render function. This is just a function, so it's outside of anything, and it says render, I don't know, message input. It takes no parameters, and then it returns an input field. You don't have JSX here, but you can create HTML using this notation that kind of looks like arrays of tags. So I can do something like this. This will be an input. And then I can specify something about it, like its type will be text. And let's just try, and here I'm just gonna call that function. So it's render message input. And here I have this input. Now I want its value to be that atom, that my message state thing. So it's gonna be message. But now I want so that I can edit this and it will actually update the state. And this is where you kind of go into this JavaScript interop, and it's just like you would do in your code. And here I can pass a function that I define elsewhere, or what you usually do is you define an anonymous function. And inside this anonymous declaration, you have this as a first argument. To define the first argument, you have this symbol of %. Now, I know it kind of looks weird, but this is it. If you have multiple arguments, it's like this. We only have one because this is just a JavaScript event on change, and that emits an event object. So that event object will be my argument in this function. And what I want to do is I want to reset the value of my atom to whatever is in the value of this input field. So I'm going to say reset, and the exclamation, the bang, means it's mutating something. So it's not usual that in a language like Clojure you change the value in something, and that's why it's like alarm, we're changing this. And I'm going to say message is what I want to change, and then pass the value. Now the value is something that I need to take from this input, and I have this argument which is the event, and you know how you would do event dot target dot value. The easiest way would be to use this called a threading operator. It has nothing to do with threads as in processes and threads. It just takes something, which is in my case this first argument, and passes to multiple functions. So the function I want to use is event.target, and then value. And now if I change this, you see that the state changes. The cool part is now, let's say this is my custom message. This is something that I have as a user put in. If I reload the page, I lose this. There's no persistency, right? It's just this object in JavaScript. And often you work on your project, you get into some state of your app, and you want to change something in your code, but then you have to reload the page and get back to that state, which is kind of annoying, especially if it's like a huge single page application. Here, thanks to Figwheel, the reloading actually injects the differences and doesn't change the state. Now let me change this h1 to h3 and save. The state persisted. the DOM actually changed, but the state is there. Oh yeah, I can do anything else, like, I don't know, style here, and color red or something. It works like that. This REPL thing is just Clojure, so something like this works. You have Clojure. This thing, CLJS user, is the default namespace, and if you have some plugin for your editor that works with Clojure, you usually have some way of like loading your code into here. But since this is just Clojure, I can just say ns, which switches the namespace. And here on top of I have demo3.core, which is the namespace of my app, and switch to that. Namespace is just like a module. So I can see what my message is, and it's an atom, which is a string with that value. If I change the state from this REPL, it will change everywhere. So from REPL, and it changed on the web page. Just now you have this completely integrated environment that you write the code, you can do whatever you want in the REPL. It's the same runtime, and you have the page which re-renders and updates as you go, and you can run functions from your code. Again, it depends on the editor, but usually they all have something like this, and you do that, and it shows you the value. And again, this is a stupid example of 3 plus 3, but mostly everything in Clojure works this way. Like HTTP requests is just something that you give a map of values and it returns you a map of values. You are encouraged to write those pure deterministic functions. This way it's reloadable, it works with this hot reloading. It's easily testable because you have few moving parts. You don't have to set up the whole thing if you want to test anything, even complex like databases. I don't know how much time that was. Hopefully perfectly 20 minutes. Questions? What questions do you have? Yep.
All the cool demos that you see online about pure functional languages are just going to go through those simple examples.
Yeah.
And you know that, right?
Yes, yes.
Okay, so when I want to choose something as a programming language, I usually go and judge it by the community around it, how human-friendly the error messages are in the compiler, or what happens when I'm stuck on some error messages. That does it have any Discord server? Does it have any Stack Overflow, things like that? Or I don't know, like how easy is it to get up and running with this language? What are the trade-offs? Could you elaborate more? I mean, how long have you guys adopted in your company? What are the challenges? What are the bad parts of Clojure? Could you elaborate more on this?
Of course. First, we haven't adopted it at our company. This is something that I just do in my free time. It is harder to find Clojure developers, of course, than JavaScript developers. Now, first point is community. It's small, nowhere near JavaScript, of course, but I found it actually really good. There is like a central place. It's a huge Slack chat called Clojurians. You can just get an invite and go there. One day I had a small problem. I went there, I posted it, and within 5 minutes I got 4 different solutions. And just anecdotal evidence, of course, but there is a Stack Overflow. And the funny thing is, if you go to Stack Overflow and you look at top JavaScript questions, there's no canonical way often that there's no standard library for JavaScript. So it's often that you see those hugely different responses. Like how do you get substring? Oh, okay, substring is like how do you get time? How do you get time? Like it's like there's no canonical one way. In Clojure, most of the time it's just one line. It is there. So if you go to Stack Overflow, most Clojure questions, and there are lots of them, have like one answer, and it is accepted. This is from the docs. I think the community is good. Like it's small, it's friendly, it's quite open. I don't know. Error messages, that's where that Java thing sometimes like emerges, and it shows you like this huge class path error in Java, and yeah. This is something the community of Clojure is aware of, and they are seeing it as a problem. And there's this article called Clojure error messages are accidental, meaning it's just useless sometimes. It's true. The thing is, if you just look at it, it's kind of bad, but if you consider how you're supposed to kind of immerse in the program, it's better, because it's not like you write this huge function and then you run it and you see the useless error message. You actually work on smallest possible pieces. And if you have something running and it is an error, you usually go inside and check the smaller parts. With the smaller parts, the error messages are more sane. Thanks.
I have a question. So, you said that like this is compiled to JavaScript, right? So, and you just said that the community is kind of small. So what if I have some, let's say, some third-party library I want to use, and they don't have their Clojure library? So how can I use JavaScript libraries, and how easy it is and stuff like that with ClojureScript?
It's easy. Like, there's nothing to do. Like, you have complete transparency into JavaScript, so you just can add whatever JavaScript you want and call functions. That's it.
So basically, when I'm requiring these dependencies on the file, the API is exactly the same as in the...
Yes, it is. Like, there's nothing new. It is, in the end, this is JavaScript running. If you open in Chrome, there are the source maps, so you will see your source in ClojureScript. So yeah, you have complete transparency. That's it.
So if it's JavaScript, can you debug it in the console?
Yes, you can debug it in the console. The cool part is, like, again, depending on the editor, you can put debug, like, stop points anywhere in your code, and then the Chrome, at least Chrome, I'm not sure about Firefox, but Chrome's debugger will actually show you corresponding ClojureScript code, syntax highlighted in the debugger, and yeah, it just works.
But if you open the console, can you put debuggers there through the console, or does it have to be in your code?
That's a good question. There is a plugin, I think, that does that. So you have to set it up in two places, like in your editor and in Chrome, and I think it works, but I'm not sure. I haven't. I'm really rarely using a debugger. Usually just printing or testing, and that works. But there is a thing. I'm sure of that. All right. Thanks.